Hi, I'm Andy, and this is my lesson on enhanced for loops in Java. In this lesson, I'll show you how to traverse an array using an enhanced for loop. I'll also show you how to avoid a common pitfall when passing an array to a constructor. Let's get started. We'll start this lesson by making a class called TestScores. As the name implies, this class will be used to store and control a group of test scores. Objects of this class will store those scores in an instance variable called scores. This class will have one constructor. The constructor will have a single parameter, the test scores that will be stored in this object. As always, the constructor needs to initialize our instance variables. In this case, there's only one, the integer array called scores. This is how we typically do that, with a very simple assignment statement. This is actually a bad way to initialize an array instance variable. We'll leave this code for now, but I'll discuss why it's bad and fix it towards the end of this lesson. Now it's time for our methods. Let's add a toString method first. I want the toString method to return a comma-separated string containing all the scores in the TestScores object. We'll start by making a string called scoreString to hold that comma-separated list of scores. We'll initialize scoreString to an empty string. Now we need to use a for loop to traverse the scores array and add each score to scoreString. We could certainly do that with a regular for loop, but since traversing an array in this manner is such a common task, the Java developers have added an easier way to do that. This new type of loop is called an enhanced for loop, or a for each loop. It allows us to traverse arrays using less code than a traditional for loop. We'll use that new type of loop here. A for each loop begins with the word for, followed by a set of parentheses. Inside the parentheses, we declare a new variable that will hold, one at a time, each element in the array. Since each array element in this case is an integer and represents a score on a test, we'll declare our variable's data type to be int and its name to be score. Then we put a colon followed by the name of the array we're traversing over. Let's look more closely at how this bit of code operates. Suppose this is our scores array. When this for loop first executes, a new variable called score is created and assigned the value of the first element in the array. Then the for loop body executes. After that, the score variable is assigned the next value in the array and the body executes once again. This continues until the end of the array is reached. At that point, the for loop terminates and the code after its curly brace executes. That's why we call it a for each loop. The loop body executes once for each element in the array, so 4 times in this example. Now that we understand how these loops operate, let's go ahead and write our for loop body. It will consist of just one line of code, a statement that appends the score and a comma onto scoreString. Now we need to return scoreString. The only problem is that since the for loop adds a comma after every element, scoreString ends with a comma. To fix that, we'll return a substring of scoreString. We want to return all the characters except for the very last one, which means we want to return all the characters from index 0 up to, but not including, index length -1. Okay, so that's the toString method. Before moving on, let's go ahead and test our code and make sure it works. Over in main, we'll first make an integer array called nums. Then we'll make a test scores object called test using that array. Lastly, we'll call the toString method on test and print the returned string. Remember, we don't need to actually put .toString here. ToString gets called automatically when you put an object reference in a print statement. Let's run our program and see what happens. Good, so that worked. Okay, let's go back to the test scores class and add another method. We'll add a method called average, which will return the average of all the scores in the test scores object. To do that, we need to sum up all the numbers in the scores array. We'll do that by first making an integer variable called sum. Then we'll use a for each loop to add each number in scores to sum. Now we can return the average. To compute the average, we simply need to divide sum by the number of integers in the scores array. But don't forget to cast one of the values in the division expression to a double so our answer doesn't get truncated. Now let's add one more method to the class. This will be a mutator method, meaning it will change the data stored in the object. We'll call that method curve. The purpose of this method is to add a curve to the test scores by adding additional points to each element in the scores array. Let's try to do that with a for each loop. Here's the code that seems like it should work, but you'll see in a second that it doesn't. Let's test this out over in our main method. After printing the original test scores data, let's add a curve of 5 points. Then we'll print out test again and see if it changed at all. Notice the test scores did not change after applying the curve. Let's figure out why. The problem with our code is right here. Remember, each time through the loop body, score is simply a variable containing a copy of an array value. So this line of code adds additional points to whatever's stored in the score variable. It does not in any way change the value stored in our array. In general, the purpose of a for each loop is to get the elements from the array one at a time and do something with them. To iterate over an array in order to change its contents, you should always use a regular for loop. Let's go ahead and do that. We'll start our array index at 0 and continue the loop while I is less than the array's length. In the body, we'll add additional points to the array element, like this. Again, for each loops are great for many purposes, but don't use one if you're looking to change the value stored in the array. Use a regular for loop for that task. Let's run our code again and make sure that fixed our problem. Okay, before wrapping up, let's look at the constructor again. I mentioned earlier that this line of code right here could give us some problems. Here's what I mean. Suppose, over in main, we construct our test scores object and then change the first element in the array that we pass to the constructor, like this. Obviously, this changes nums, but it certainly shouldn't affect our test scores object, right? Let's see. Okay, so the data in test also changed. This is a big problem. We want our data in test to be encapsulated. We want to protect it from being changed except by using mutator methods we provide in the class. To see why this happened, we need to think deeply about exactly what happened when our constructor executed. First, consider this line of code. It creates an integer array and stores its address in a reference variable called nums. Then we create the test object, passing nums in the constructor. When that happens, the value stored in nums gets copied into this parameter. But remember, nums is not an array. It's a reference to an array. That means the address stored in nums gets copied into the scores. So now we have two references to the same array. Then this line of code executes. It copies the address from the scores into scores. So now we have three references to this one array. Once the constructor ends, the constructor's formal parameter is released from memory, leaving just these two references to the array. Now, back in main, this line of code executes, changing the first element in the nums array. But that's also the array referenced by the scores instance variable in our test scores object. That's why its data changed when we printed it out. To fix this problem, we want the test scores object to have its very own copy of the array. We do that in the constructor. First, we'll make a brand new array that's the same size as the scores. Then we'll use a for loop to copy the values from the scores into scores. Since we are modifying the values in our array, we need to use a regular for loop to do that task. Then in the for loop body, we simply copy the value in slot I of the scores into slot I of scores. And with that change, our test scores object should have its very own array that is protected from outside manipulation. Let's run our program again just to make sure. Good, so it looks like the scores array did not change. So for now on, make sure you always make a copy of past arrays in your constructors. Otherwise, your object data is not truly encapsulated. And that wraps up this lesson on enhanced for loops in Java. I'm Andy. Thanks for watching and coding with me today.